Hello everyone, today we're going to be working on fundamental problem 6.9, and this problem is saying to determine the force in members KJ, KD, and CD of the truss, to state if the members are in tension or compression, and to take that P1 is equal to 22 kilonewtons, P2 is equal to 33 kilonewtons, and P3 is equal to 44 kilonewtons. So to start off this problem, the first thing that I'm going to do is I'm going to decide where I'm gonna cut the truss, exactly how I'm gonna cut it. And one thing to keep in mind is that when you're determining where to put the cut, is to make sure that it passes through all the members that is asking you to determine their force. So in this problem, or in this example, I'm gonna cut the truss right here because that way it would cut the member KJ, it would cut in between the member KD, and it would cut in between the member CD, which are the three that we have to determine the forces. So I'm gonna do the cut right here. So now that I have cut the truss into two parts, now the next thing that you want to do is you want to analyze both sides of the truss to see with which side of the truss it would be easier to work with. So if we were to take a look at our left side, we would see that with our left side, we would be dealing with two forces, two known forces, and then we have a support right here, which is a pin support, meaning that we're going to have two reactions there. So if we were to work with the left side of the truss, the first step would be to determine the values of both of these reactions. And then from there, we would be dealing with 1, 2, 3, 4 forces plus the forces that we're trying to determine of each of the members. Now, if we were to deal with the right side of the truss, we would be dealing with one known force. And right here at point G, we have a roller support, meaning we would just have to determine one reaction right here. So in the end, we would be dealing with two forces and then the three unknown forces that we're trying to determine. So because of that, I'm going to be working with the right side of the truss. You could work with the left side of the truss, but just to make things easier and quicker, I'm going to work with the right side of the truss. So to work with the right side of the truss, the first step that we have to do is we have to determine the value of our vertical reaction at point G. So what I'm going to do is I'm going to take the sum of the moments about point A. That way these two unknown reactions will not be creating a moment. And that way we'd simply just be able to solve for the value of our reaction at G. So if we were to take the sum of the moments about point A, we would have our three forces. They're both to the right of our point A, and they're all going downwards. So we know that all of them are going to be creating that clockwise moment, meaning a negative moment. So they're all going to be creating negative moments. So negative moments. So remember that a moment is equal to the force times the distance. P1 is 22 kilonewtons, P2 33, and P3 44. So the first one we said has a force of 22 kilonewtons, and remember, moment is equal to the force times the distance. From point A to where our force is, we have a distance of 2 meters. From there, we have our second force has a value of 33 kilonewtons times the distance from here to here is 4 meters. So times 4 meters. And then our last one is 40 has a force of 44 kilonewtons times the distance of from here to here is there's a total distance of 6 meters. So times 6 meters. And then from there, our last force that's going to be creating a moment is our reaction of G of Y. Since it is a roller, it's going to be a vertical reaction. I'm going to assume that it is going upwards. So we're going to call it G of Y. So since I'm assuming that it's going upwards, and since it's to the right of our point, we know that it's going to be creating a clockwise moment then, meaning a positive moment. So a positive moment of a force, that's what we're trying to determine. So g of y times the distance. So from here to here, we have a total distance of 2, 4, 6, 8, 10, 12 meters times 12 meters, and all of that has to equal 0. So from here, we would simply just solve for g of y, and we would end up getting that our reaction g of y equals 36.7 kilonewton meters. And since we got a positive number, that means we assumed correctly the direction of our reaction. So we do know that that reaction will be going upwards. So now that we know the value of our reaction, we could simply just replace it. 36.7 kilonewtons going upwards. So what I like doing is I usually like drawing out the truss beforehand, the side of the truss that I will be working. So I already drew it on this side. I'm simply just going to move it over. So as you guys could see, now this is an image of the right of the truss, the side that we're going to be working with. So now we're going to start using the method of sections to determine the values of each of those members. So what I'm going to do is, what I like doing is I first like taking the sum of the moments about a point where two of those members meet, because then that way they will not be creating a moment and I would be able to solve for the force of the other unknown member. So if we take a look here, we could take the sum of the moments about point D. That way the force of the member KD and CD would not be creating a moment, and that way I'd be able to solve for the value or for the force of the member KJ. So that's going to be my first step, taking the sum of the moments about point D. So like we said, these two would not be creating a moment, as well as the 44 kilonewtons. So the only two things that are going to be creating a moment is our reaction force and the force of the member Kj. So if we were to take a look at our force Kj, I'm assuming that all of the forces right now, or all the members, are going to be in tension. That's why I drew the forces going away from the joint. You could also assume that they're in compression. It doesn't matter, but I'm just going to assume that they're in tension. So in this case, for our member KJ, we have it in tension. So that means in this case, it is going to the left. So since it is above the point D and going to the left, we know it's going to be creating that counterclockwise moment, meaning a positive moment. So we have a positive moment with a force that we're trying to determine. And then the distance, we know that from here to here, it's given to us that there is a distance of 3 meters. So that is our distance. So we have positive moment of the force of the member Kj times 3 meters. And then from there, we have our reaction. This reaction will also be creating a positive moment since it is going upwards and to the right of the point. You could see that it will be creating also a counterclockwise moment. So a positive moment with a force of 36.7 kilonewtons times the distance of, we know that from here to here, we know that each of these has a span of 2 meters, so with a total distance of 6 meters. And then all of that has to equal 0. From here, we would simply just be solving for the force of the member Kj. And we would end up getting a value of negative 73.3 kilonewtons. As you guys could see, we ended up getting a negative number. That means that we assumed incorrectly, and that actually means that this member is going to be in compression. So with that, we were able to determine one of the member's forces. Now from there, I'm going to take another look and see where two more forces meet together. As you guys could see, our force of our members K, D, and KJ also meet up at our point K, meaning that if I were to take the sum of the moments about point K, we would be able to determine for the force of the member CD. So that's what I'm going to be doing next. So if we were to take the sum of the moments about point K, we would end up getting, so we have our force CD. We have it, since I assume that it's going to be in tension, we have it going to the left. So for about point K, we know that it's going to be creating that clockwise moment, meaning a negative moment. So we have a negative moment of our force CD times. We know that from here to here, there is a distance of 3 meters. 3 meters. From there, we have our 44 kilonewtons. We know that it is going downwards, so we know that it's going to be creating also a clockwise moment, meaning a negative moment. And then from there, we know that there is a distance of, we know that from here to here, there is a distance of 2 meters. So we have, once again, negative moment of 44 kilonewtons times 2 meters. And then from there, we have our reaction of 36.7 kilonewtons. About point K, we know it's going to be creating that counterclockwise moment, meaning a positive moment. So a positive moment of a force of 36.7 kilonewtons with a distance of 2,468 meters. Because from K to point G, there's a distance of 8 meters. So times 8 meters. So positive moment, force of 36.7 kilonewtons times 8 meters. All of that has to equal 0. Let me plug this into my calculator real quick because I forgot to do that earlier. So from here, we would get the negative force of the member CD times 3 meters. And then from there, we would get negative 88 kilonewton meters plus we have 36.7 times 8. We would get positive 293.6 kilonewton meters. All that has to equal 0. So from there, we would end up getting that the force, the member CD times 3 meters has to equal negative 205.6 kilonewton meters. And then from there, if we were to divide both sides by 3, we would end up getting that the force of the member CD is equal to 68.5 kilonewtons. And since we got a positive number, that means that we assumed correctly. So we do know that this member is going to be in tension. So now we have found two forces of two members. So from there, as you guys could see, the missing member that we have left is the member KD. As you guys could see, KD is at an angle, meaning that it will have a vertical and horizontal component to it. And because of that, we could either take the sum of the forces in the y direction or in the x direction. So you could do either or. In the end, you should get the same answer. I'm simply just going to be taking the sum of the forces in the y direction. That way, I would be using my reaction and the given force that was given to us. But before doing that, Since it is to an angle, we have to determine some geometry to it to be able to determine the vertical component of that. So looking back over here, we know that this side has has a length of 2 meters. This side has a length of 3 meters. So remember, you guys, if we're trying to find the hypotenuse side, we know that a squared plus b squared is equal to c squared. So we're quickly going to use that to determine the length of the hypotenuse. And we end up getting then that this length right here is the square root of 13. I'm going to quickly erase the cut. So we know that this side has a length of the square root of 13. So since we're trying to determine the value, the vertical value of this force, what I'm going to be doing is I'm going to be multiplying the force of the member KD by 3 over the square root of 13. And that is because I'm trying to find the vertical component of it to it, and I'm dealing with the hypotenuse side. Now, if you were to take, now if you are taking the sum of the forces in the x direction, so you're trying to find that horizontal component of it, you would be multiplying your force by 2 over the square root of 13, since you want to find that horizontal component to it. So that's what I'm going to be doing. So upwards positive, the sum of our forces in the y direction have to equal 0. We have our negative 44 kilonewtons. Since our 44 kilonewtons are going downwards, that means they're negative, plus our reaction that is going upwards, that's why it's positive, 36.7 kilonewtons. And then from there, since I assumed that my members would be in tension, in this case right here, our member KD, the force of our member KD is going away from the joint, so it is going upwards in this, because I guessed that it was going to be in tension. So positive, so we're going to have a positive force KD, but since I'm doing the sum of the forces in the y direction, I have to determine its vertical component, so I'm going to be multiplying that by 3 over the square root of 13, and all of that has to equal 0. So from there, we would end up getting 3 over the square root of 13 times the force of KD has to equal 7.33. So from there, we would simply be getting that our force of our member KD is equal to 8.81 kilonewtons. Since we got a positive number, that means that we assumed correctly, meaning that it will be in tension. And with that, we are done with our fundamental problem 6.9. So once again, and how we started off this problem is we first located our members that we are asked to determine their forces. From there, we would see how our cut would be able to go through all of those members. So in this case, the cut was right there. From there, you will want to analyze the right and left side of the truss, determining which one would be easier to work with. We worked with the right side of the truss, since that way we would only be having to find one value of one reaction, as compared to this side, we would be having to find the value of our vertical and horizontal reactions. So to find the value of our reaction at point G, we took the sum of the moments about point A. That way these two reactions would not be creating a moment, and being able to solve for our reaction G of Y. And then from there, we would just simply use the method of sections to determine the rest of the problem. I drew out the right side of the truss, and then from there, I just started taking the sum of the moments about a point where those two members would connect or would join, and that way I'd be able to solve for the other force or the other member. We did that for 2 2 points, and then from there, since our force KD was at an angle, we know that we could either take the sum of the forces in the y or the x direction, since it has both a horizontal and vertical component to it. Thank you guys so much for watching this video. If you guys found this video useful, please feel free to give it a thumbs up, and also feel free to subscribe to our channel if you guys would like to see more videos like this one.